Okay, guys, we got example two, and this is a really, really fun equation, guys. It looks really nasty. 27 to the x minus 1 exponent equals to 3. You say, what? How can that be? Well, let's remember, guys, if you see, look for the lowest number and see, look at the relations. It's like looking for cousins, personal, what they have in common. And here we see that the base that they have in common will be 3. Can you see it? Somehow we're able to do that. So let me just show you what you say. Well, the base has to be 3 has to be the base. So 3 has to be equal to the base. Okay, we know that on one side we had 3 to the first. That's to the 3. But what about over here, guys? 3 times what power? And then of course we have x minus 1. Okay, so we try different things, guys. Let's try it on the side. So we went 3 to the second power, that's 3 times 3, which is 9. Oh, that's too low. It's not 27. What about 3 to the third power? Well, that's 3 times 3 times 3. Oh my gosh. This would be 9. 9 times 3 is 27. This is it right there. So you come and you say, hey, that's a 3 right there. And you know when you have a power by a power, you multiply it. So now what you're going to do here is multiply 3 times this whole thing right there. Okay. So you're going to say, well, what I have here is 3 times to the third power, x minus 1 equals to 3 to the first power. So if that is equal to, like we said before, if we have the bases, then we can forget about the bases and concentrate on making the powers equal to each other. And you say, okay, so this is going to equal to that. So you come over here and you say, okay, let me rewrite that. What I have is 3 times x minus 1 equals to 1. And you can use the distributive property right here real quick, guys. You're going to get 3x minus 1, and that is still equal to 1. Oh, no, sorry. I forgot. This would be 3, right? Yeah. Now I need to add plus 3 to both sides, plus 3 to both sides. I got 3 equals to 4. I divide both sides by 3, right? And I'm done. See? Then I got x equal to 4/3. 4/3, guys, or some of you will say, or 1.333, whatever. Okay, either or, we will take it. Okay, so let me just go here, just real quick. Let me do it again. Okay, we figured out here, guys, and we figured out that if we were to get this, guys, right here, we found the base, which was 3, and then we know we're going to multiply that times that, and these ones will go away, and we're going to get 3x minus 3 equals to that. Can you see that? And yes, yeah, yes, I'm going just a little bit forward here, guys. So I got 3x minus 3 equals to 1. Okay, and that's when, and then I added to it, and then of course I just went to add and do whatever, plus 3, and I ended up with 3x equals to 4. Then I divided everything by 3, and I got x equals to 4/3. I hope that helps a lot. So with that in mind, guys, let me try a similar one, and let me just go here real quick, and let's see if you guys can see exactly how the steps that we're gonna do. But it's really really simple, guys. Let's okay. Let me just clear this puppy out. So what if I had something like I don't know, let me see, um, 4 square equals to, then I'm going to get here like, let me see, 16 times 4x plus 1. Okay, let me erase that just a little bit real quick. 16 to that 4x plus 5. Okay? And you say, wait a minute, I can either use the base 2 or I could just leave the 4 because I can do that. Okay? Here, and you will get the same answer, guys. If you were to use the base 2, so the base is here to really, the base, because will be 4, right? 4 will be great. And then, so we leave the 4, and you say, okay, you will say 4 right there to the second power equals to 16. Well, 16, 4 times what will give us 16? And again, you'll see, oh my gosh, that's not bad at all. That's not bad at all. That will be 2 as well. See that? But here we're going to get 2 to the 4x plus 5. The bases are the same. So I end up with, and then I'm going to go here and here, guys. So I'm going to get 2 equals to 8x plus 10. Okay? And let me see if you can see that, guys. I'm going to come over here and I'm going to subtract 10. Subtract 10. So I'm going to get negative 8 equals to 8x. See that? Then I'm going to divide both sides by 8. 8. And I find that x equals to negative 1. There it is. Okay? So if I was to put a negative 1 in there, in here, you will see that if I was to substitute it here, it will be negative 1 times 4 will be negative 4. Negative 4 plus 5 will be 1. 16 to the first power will be 16. 4 to the second power will be 16, so it will check. It's just one of those nice ones that really lend itself for scrutiny right there, guys. So the bases are the same. Then you can multiply, do distributive property, and then equal to each other, and you're done. Isn't that cool, guys?